So let's talk about levers. This is another one of these simple machines. And if you think about how lever works, then you've got a fulcrum right here, and you've got a mass right here, and you want to exert a force down right there to lift the mass. So equilibrium occurs when the clockwise torque equals the counterclockwise torque. Well, the clockwise torque is going to be the force that you apply times this distance r1. So that's F times r1. That counterclockwise torque is going to be the mg times r2. So the F is going to be equal to R2 is going to be equal to R2 divided by R1 times mg. Okay. Well, what that means is that in the case I've drawn it right here where R2 is bigger than R1, that means you have to apply a bigger force than the weight. Well, that's not very efficient. Okay. But if you readjust things here, so now R2 is less than R1, okay, then now the F R1 equals mg R2, so now the F is equal to R2 over R1 mg, and now you notice, wait, now we have a mechanical advantage because R2 over R1 is going to be less than 1, and so when that happens, it means that a smaller force is able to lift a heavier object. And so that's the idea of mechanical advantage, that you actually get something. It's like magnifying the effect of your force. So that's a lever right there. Another example of a lever would be, for example, a wheelbarrow. With a wheelbarrow, then you've got the mass right here, mg, okay, and you're pulling upward with some force right here. Well, the center of mass to the mg we can call R2. We can call R1 to where your hand is lifting upwards, so R1F equals R2 mg. So again, F equals R2 over R1 mg. So again, as long as R2 is less than R1, that means that R2 over R1 is less than 1, and we have a mechanical advantage. That the force you lift right here, pulling upwards, is less than the mg, the weight of the thing you're trying to carry. So in other words, you have like a 100-pound bag of concrete, and you put it in a wheelbarrow, and as long as it's in the front part of the wheelbarrow, then you don't have to lift as hard this way. So you might only have to lift, with 20 pounds of force to hold the 100-pound bag of concrete. Now, if you put it in the back part of the wheelbarrow, however, then you have to lift with a bigger force. So you always want to have it towards the front in order to maximize the mechanical advantage. Likewise, a pry bar, okay, so you got a crowbar or something, and so you've got some long distance D here, and you're trying to pull a nail or something out, so you pull down the force here, okay, and that force tries to rotate it this way. That means that this is putting a force that way. Newton's third law says you're exerting a force that way on the object. So you're pulling a nail out of something, and so we'll call this F1, call that F2. So F2D has to equal F1L, okay? And so that means that F2 is going to be equal to L over D F1. Now, notice L is bigger, so that means the force 2. This force is amplified what that force is. And so again, you have a mechanical advantage here in that you are amplifying the effect of your force. So again, this is another example of a similar concept here. You got a nail in a piece of wood, and you want to pull it out. Now you could just like try to grab it and pull it up, but that takes a lot of force. So instead, what you do is you use the claw of a hammer, okay? So you use the claw of a hammer, okay, and then what you do is you pull this way, and the nail is right there, and so it's pivoting about some point here. So there's your pivot right here, and so that force times that distance right there, L, and this distance D, and then this force right here, this F1 and then F2, okay? And so again, dF2 is going to equal LF1, and so F2 is going to be L over dF1, and again, that means that this force is going to be bigger than that force. That's the whole idea of how claw hammer is able to pull things out. Well, what that means, though, is if you want to have the maximum effect, then you need you need to figure out, where you want to put, where in the claw that you want the things to be. So anyway, so this is again, these are the idea of levers, okay, and how you would use levers and leverage.